Hello everyone, I welcome you all for today's lecture series on municipal and industrial wastewater treatment. The topics covered in the last session was on cast iron sewers, plain cement concrete or reinforced concrete cement concrete sewers, corrugated iron sewers, plastic sewers, steel sewers, vitrified clay or stoneware sewers, wooden sewers, and shapes of sewers. So these are the things which we have discussed in the previous lecture, where in case of a cast iron sewer, we discussed the properties of a cast iron, its manufacturing process, its advantages and disadvantages. Simultaneously, the topics to be covered in this session will be on box or rectangular type sewer, egg-shaped sewer, basket-handled sewer, horseshoe sewers, parabolic sewers, semi-elliptical sewers, and laying of sewers. The learning outcome of today's lecture series, you will be able to understand different shapes of sewers and you will be able to know laying of sewers. Let us discuss one by one box or rectangular type sewers. In olden days, these sewers were constructed by laying concrete at bottom and constructing the sides with a masonry. But nowadays, masonry has been completely replaced by concrete. These are mainly used for outfall sewers. They have got relatively high hydraulic mean depth at large flows and therefore can have higher velocities when laid to the same slope as that of a circular or a egg-shaped sewer. They are therefore most suitable for large size storm sewers. The next one is egg-shaped sewers. So it is also called as an egg-shaped or ovoid section. This shape has got better hydraulic properties, but it is costly. Firstly, due to longer perimeter, more material for construction is required. And secondly, because of its odd shapes, it is difficult to construct. This type of sewers is suitable for carrying combined flow. The main advantage of this type of a sewer is that it gives slightly higher velocity during low flow than a circular sewer of the same capacity. This sewers requires always a good foundation and proper reinforcement to make structurally stable. In India, they are rarely used, but construction of this section is difficult and less suitable than circular section. They are most suitable in case of combined sewers. Inverted egg-shaped sewers gives better suitability and carries heavy discharge. The main advantage of the sewer is that it gives a slightly higher velocity during low flow than a circular sewer of the same size. So this is the schematic representation of egg-shaped sewers where the first diagram indicates standard egg-shaped sewer and The other one indicates new modified egg-shaped seaver. Next, let us discuss about basket handle seaver. In this type of a seaver, the upper portion of seaver has got the shape of a basket handle. The bottom portion is narrower and carries small discharges during monsoon, and combined sewage is carried through the full section. Small discharge flow through the bottom narrower portion. During rainy days, the combined sewage flows in the full section. This shape of sewer is not generally used at present. So this is the schematic representation of basket handle section. Next, let us discuss about horseshoe sewers. This type of sewers are used for the construction in tunnel to carry heavy discharges such as truck and outfall sewers. This is also suitable when the available headroom for the construction of sewer is limited. The invert of the sewer may be flat, circular or paraboloid, and top is semicircular with a side vertical or inclined. It is mostly used for the sewers in the tunnels and used for the construction of large sewers with a heavy discharge such as trunk sewers. So this is the schematic representation of horseshoe sewer section, where the structure or the cross section of this type of a sewer resembles horseshoe. Now let us discuss about parabolic sewers. In this form of a sewers, the upper arch takes the shape of a parabola as shown in the diagram. The invert of the sewer may be flat, parabolic or elliptical. They are used for the disposal of relatively small quantities of sewage. This type of a sewage sewers are suitable for carrying comparatively small quantities of sewage and economical in construction. The invert of sewer may be flat or parabolic, and upper arch of the sewer takes the form of a parabola. Now let us discuss about semicircular sewers. This type of sewers are suitable for constructing large sewers with a less available headroom, and it possesses better hydraulic properties. The semicircular sewer gives a wide care at the bottom, and hence it becomes suitable for constructing large sewers with a less available headroom. Nowadays, these are replaced by rectangular sewers. Now let us discuss about semi-elliptical sewers. This type of a section or a sewer is suitable to carry heavy discharges and adopted for soft soil as it is more stable. This shape is not suitable for carrying low discharges, and it is normally adopted for sewers having diameter greater than 180 centimeter or so. The diameter of sewer may be more than 180 centimeter or 1.8 meter and possess good hydraulic properties except at low depths. So this is the representation of semi-elliptical sewers. Now let us discuss about U-shaped sewers. The shape of this section is the true shape of letter U as shown in the figure, or small trench or a U shape can be set up in the large section of sewer. The trench is known as the connect and adopted for a combined sewer having predominant flow to stormwater. Their invert may be flat or a semicircle. The sides are generally vertical and top may be flat or arched. Now, before beginning to laying of sewers, let us discuss what are the brief description and choice of types of sewers. While selecting the sewers, following considerations should be taken. The selection for the materials of sewer. First one is cost consideration. The cost should be moderate and reasonable. Durability. The material should be durable. The material of sewer should be impervious nature. The material should possess enough resistance to abrasion caused due to grit moving with a high velocity. The material should be capable of offering resistance to the corrosion because the sewage possesses corrosive qualities. The material should possess moderate weight so as to make easy handling and transportation. Next, let us discuss about laying of sewers. After the sewer plan has been approved, the next step is to set up the work. The center line of the trench is first staked out on the ground. The center line pegs are driven at a distance of 7.5 meter or 15 meter respectively. The site rail and boning rod system is the accepted method for laying the drains accurately to the gradients indicated on the plans. Site rails are set at all changes of gradients and at intermediate positions if the distance for siting is large. The site rails are set in such a way that the line sighted along the top edge of the rails represents the true fall of the sewer. This gradient is shifted below the ground level by means of a traveler or a fixed length. Site rails are the horizontal cross rails placed on uprights. They are usually made up of a good straight piece of timber of 15 cm width and 5 cm thick, and length to extend over the width of the trench. So the construction of sewer consists of the different works like marking central lines of sewers, excavation of trenches, checking the gradient, preparation of bedding, laying of sewers, joining and backfilling. Now let us discuss one by one. Marking central line of sewer. The center line of a sewer are marked on the streets and roads from the plans starting from the lowest point of outfall of the main proceeding upwards. The setting out of work is done by means of chain and theodolite or compass. For checking the center line during the construction, generally wooden pegs or steel spikes are driven at 10 centimeter interval on a line parallel to the center while laying sewers. They will not disturb them. For checking the levels of sewer pipes and their alignment, temporary benchmarks are established at 200 to 400 meters intervals. The reduced level of these benchmarks should be calculated with respect to GTS benchmarks on the centerline position of sewer apparatuses are also marked. So this is the first process of laying the sewers. The next process is excavation. trenches. After making the layout of the sewer line on the ground, the first step is the removal of pavement, which starts from the lower end of the sewers and proceeds upwards. Spade or pneumatic drills can be used in case of removing concrete pavers or pavements. After removing pavements, the excavation of trenches is done manually or machinery. The width of trench depends upon the diameter of sewer and depth of sewer line below the ground level. The width of sewer line is 15 centimeter more than external diameter of sewer for easiness in lowering and adjusting the sewer pipes. The minimum trench width of 60 to 100 centimeter is necessary for conveniently laying and joining of each, even when small size sewers. The excavation of trench sites require shorting and shuttering, and also dewatering is done by gravity method or pumping method. The next process is preparation of bedding. Trenches are excavated with a proper grade so that sewage may flow in sewer due to gravitational flow only. The center line of sewers and their grades are transferred from the ground by means of site rail and boring rod. When a sewer has to be laid in a soil underground strata or in a reclaimed land, the trench shall be excavated deeper than what is ordinarily required trench bottom or rock. In the same case of very bad soil, the trench bottom shall be filled in with cement concrete of appropriate grade. In areas subjected to subsidence, the pipe sewer shall be laid on a timber platform or concrete cradle supported on piles. In the case of casting site sewers and RCC section with a reinforcement, bearing capacity is encountered and soil stabilization shall be done, either by rubber, concrete or wooden crib. The various type of pipe bendings depends upon the size. Next process is laying of pipes. Smaller size pipes can be laid by the pipe layers directly by hand only, but heavier and larger size pipes are lowered in the trenches by passing ropes around them and supporting through hook. It is the common practice to lay the pipes with their socket end upgrade for easiness in joining. After lowering the pipes, these are brought near and spigot end of one pipe is placed in the socketed end of the other. After properly placing and arranging the pipes, they are suitably joined. The joints are carefully cured for sufficient time. Next process is joining of sewer. So this is the last process of laying the pipes, sewer pipes. The cast iron pipes shall be examined for line and level, and the space left in the socket shall be filled in by pouring molten piglet or best quality. For concrete pipes, the collar shall be placed symmetrically over the end of two pipes, and the annual space between the inside of the collar and the outside of the pipe shall be filled with soaked in tar, or cement slurry tampered with just sufficient quantity of water to have consistency of semi-dry condition. Well packed and thoroughly rammed with chalking tools and then filled with the cement mortar in the ratio 1:2. The joints shall be finished off with a fillet sloping at 45° to the surface of the pipe and cured for 24 hours. Any plastic solution or cement mortar that may be have squeezed in the pipe shall be removed to leave the inside of the pipe perfectly clean. For stoneware pipes, all the joints shall be chalked with a tarred gasket in one length for each joint and sufficiently long to entirely surround the spigot end of the pipe. The gasket shall then filled with 1:2 cement sand mortar in a semi-dry condition, and a fillet shall be formed around the joint with a trowel forming an angle of 45° with a barrel of pipe as per IS standard 4217. Rubber gasket may also be used for joining. So these are the different steps which are used while laying the sievers. So traveler or boning rod contains of a rod and a T-piece. It is most important that boning rod should be cut to the exact length required, otherwise the pipes may not be laid correctly to the required grade. The boning rod may be 8 cm by 4 cm timber piece of a required length. Since the work of laying pipes is generally started from the lower end, the side rails will therefore be required to fix at these points. After fixing the first set of side rails at the tower end, a second set of side rails is similar set at some distance upstream side. Knowing the reduced level of invert of the sewer at the lower end and the desired gradient of the sewer line, the reduced level of invert at the second set of side rail is calculated. The depth of invert below both the side rails should be the same to obtain the desired correct gradient, because the top of these side rails are adjusted to the correct reduced levels according to gradient required. So these are the few questions for practice, but before that let us put a glance on the things which we have discussed in the today's lecture session. So in the today's lecture, we discuss about box or rectangular type sievers, egg-shaped sievers, schematic representation, basket-handled siever, horseshoe sievers, parabolic sievers, semicircular sievers, semi-elliptical sievers, U-shaped sievers, and laying of sievers. In case of a laying of sievers, there are different steps to be adopted, like marking central line of sievers, excavation of trenches, checking the gradient, preparation of bedding, laying of sievers, joining, and backfilling. So these are the few steps to be adopted while laying the sievers. And while selecting the type of a sievers, it is necessary to check out the cost consideration, durability, imperviousness, resistance to abrasion, resistance to corrosion, and weight. So these are the few steps adopted, which we have discussed briefly, and these are the questions which may likely to be asked in the examination, that is on explain box or rectangular type sievers, explain egg-shaped siever with a neat sketch, explain basket handle siever with a neat sketch, explain horseshoe sievers, parabolic sievers, and semi-elliptical sievers with a neat schematic representation, and briefly explain laying of sievers. So make sure that you are going to write all the points with a neat diagram. So this is all for today. Let us meet with a new session. Thank you. Thank you very much.